Hello, everybody, and welcome back to the Daily Challenge with Po-Shen Loh. We'll be doing the daily live stream again today. I hope that everyone had an interesting day in the last 24 hours. Here we're going to do what we have always been doing, which is to go and have a conversation ranging through different areas of mathematics based on what people are interested in. I will say, I have actually just realized that our particular recording device hasn't yet started for our video. So I'm about to go and press the video start, and then I'll come right back here, and then we'll go on. I'm saying this because, you see, to me, there's no point wasting a good opportunity. And so whenever I do spend these hours talking to everybody about math, we're actually recording everything that we have, so that someday we might even be able to make a best of, or put everything together in a better format even than what we have on the YouTube Live. For example, you may have noticed that, with this way of learning, oh, somebody said I'm on mute? No, I don't think so. I think we're okay. Yeah, so as you may have noticed, this conversation is ranging through lots of different topics every single day, which is interesting and fun, and that's sort of the goal of this. But I've also said before that the goal of this daily live stream is not to be a math course, because of the fact that it is, in some sense, jumping between topics. So we'll actually collect all of these to make something interesting later on. So if you'll excuse me for about 2 or 3 seconds, I'm going to start the recording device on our camera. You'll actually still be able to hear and see the rest of the studio in the meantime. One moment. Hello again. Great. So as usual, I'm always curious to know what kind of background everyone has. And I've also updated the description this time because I was looking at the restrictions quite carefully. We do need to respect the laws. And so we've put quite clearly in the description that this live stream is directed at people who are 13 or older. And so in particular, the kind of math that we're going to talk about is the kind of math that you would typically learn if you were 13 or older. And now, so that I can understand what people are learning in school, could you maybe post into the chat what math you're studying right now? And I'll be looking at this because that will help me to go and find out what kind of level we should be talking about today. As people are posting into the chat, I will also say quite clearly, our goal is to try to help as many people as possible see that math is interesting. And so I'll always be trying to choose questions that are as accessible as possible. I see. So I see a lot of this Algebra 1. We are starting to get some high school, some of these Algebra 2, and so on. I see algebra, I see geometry, I see people who are doing math, which is somewhat in this range. And so, as usual, I think we're going to try to target that level sort of between algebra and geometry. If I see something that's more sophisticated, I see pre-calc too. If I see something that's more sophisticated that's asked here, for which I can give you some kind of an interesting answer that's also understandable to students who are studying math that's before, I will of course try. So, what kind of questions do we have here? I'm looking to see what kind of questions people might have asked. The way that we do this is that if you put some kind of a question that will inspire me maybe to talk about a particular area of math or a particular thing. Have I solved coronavirus yet? No, unfortunately not. But I'll also say it's not a single-handed thing. It's not like I personally can solve the whole coronavirus. In some sense, everyone has to work together. Oh, I see somebody has asked how to do algebra. That's a fun question. Let me hit that while people are still asking questions. And we're lucky enough that our team of moderators is also helping to pick out some of the best questions. So feel free to keep asking as you're going, because they're going to find some things that maybe I can pick up and answer. But the question of how do you do algebra, let me tell you what I do whenever I do algebra. I look at the equation I might have, I look at the problem I might have, and then I just remember one thing. Whenever I'm trying to do anything with an equation, you just remember that the equal sign is the fundamental concept in algebra. For example, if I have some equation, I'm making up an equation, like 2x plus 3 equals 2 minus 7x. Okay? Let's try that. Minus 7x. If I see that, the way I deal with this is I just do the same thing to both sides enough times until x is alone. for me, algebra just has one very important concept, which is the equal sign. And then you're allowed to beat up one side as much as you want, as long as you beat up the other side the same way. And at the end, when you have x equals something, you're done. So you just start beating them up. You go like, oh, let's just add 5 to both sides. 2x plus 8 equals 7 minus 7x. That didn't seem so useful. Let's divide both sides by 7. Okay, 2/7 x plus 8 over 7 equals 1 minus x. I know some people here are saying, what's this guy doing? But I'm just trying to illustrate the point. Oh, let's just add x to both sides, see what happens. If you add x to both sides, 2/7 plus 1/7 is 9/7. 9/7 x plus 8 over 7 equals 1. I almost have x alone. Let's just try subtracting 8/7 from both sides. 9 over 7x is equal to minus 1/7. Hope I didn't make a mistake by now. And now it looks close. See, it looks like I could just try to multiply both sides by 7, get rid of the denominator. 9x equals -1. And let's divide both sides by 9. X equals minus 1/9. Is that actually correct, guys? Oh, it is! Yes! Jack said twice. Yes, so -1/9. Looks like that was the right answer. Now you might say this is an extremely inefficient way to solve the equation. However, I'm just trying to show you that no matter what, you can just go and fight with something and eventually it will fall apart. You just have to try hard enough. Just like the coronavirus, same idea. So to me, this is how you do algebra. You just start beating up both sides of the equation until things work out, just remembering that you have to be fair to both sides. Okay, there are also other concepts too. There are concepts like graphs. There are concepts like what to do when you have an x squared. All of these things can also be dealt with in some sense with your wits, but it helps, of course, to have some more concepts. That's where your teacher is also helpful. But I'm going to emphasize that whenever you look at any topic in algebra, as I said, there aren't that many concepts. I just showed you the equal sign, and that also there's a notion of graphs. Once you understand what a graph is, you can reason about it. There are notions of quadratic equations. Once you sort of understand that, you can reason about it too. But to me, algebra is not a very huge, complicated subject where there are lots of little recipes that you use for any particular problem. I actually was thinking about this a lot when we were filming our daily challenge course, the official course on algebra. Because when I was doing this, I was thinking, what is there? What do I need to show? And ultimately, I decided you can actually just try to show everything where people just try to intuitively work through any problem that's new, where they just use these ideas of the equal sign, or maybe graphs or some other concepts. Okay, so let's look at some kind of other questions. Oh wow. I see some very funny things. Iris Jin says, apparently you're good at singing. Can you sing for us? Oh my gosh, you're challenging me to do this? I haven't warmed up at all. So I think I'm gonna try. I'll try a song that maybe you might have heard of before. It goes like this. And again, I haven't warmed up at all, so this could be completely off key. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now there's a reason I chose that song, by the way. And the reason is because maybe you've heard of that song before. Apparently in the United States, that's how a lot of people memorize the quadratic formula. But I'll say that song to me is a little bit boring. That's just the what is it? Pop Goes the Weasel or something. If you want a song for the quadratic formula, I highly recommend you go and check out XP's new music video, which is a rap music video with a different quadratic formula song that's a lot more catchy. So if you just go look for XP, that's EXPII in YouTube, and look for the quadratic formula music video rap, we've got something better for you. Okay, let's hit some other questions. Okay, wow. So I see a couple of questions. Some of these I won't go into detail only because I know that not everyone can understand. I saw somebody saying, do the proof. Winter Rain asked, could you please do the proof for the shoelace formula? And that is this area formula for a triangle. That one's actually quite hard to do in a way that everyone can understand. But what I will say is that one of the concepts at the heart of it is actually something related to matrices. Matrices are what you see if you're solving two equations with two unknowns or more equations with more unknowns. Let me show you what I mean. So I'm going to just write down some equations with like x and y, and I'll tell you it has some connection to these things called matrices. So if I wrote down some equation, I don't know, 2x plus 3y equals 4. That looks like a nice equation. Let's make another equation. X minus y equals, I don't know, what should we do? 1? Hopefully the numbers are small enough that I can do something interesting. So when you write down something like this, what do? How do you solve this type of equation? Well, it's kind of helpful to try to put the x's in a column and the y's in the column and the numbers in a column. And although I said you kind of beat up these equations as much as you want. Now Gauss is a famous mathematician and physicist. Well, and lots of things. He was a genius, but he realized that you can use a technique that anonymous cheetah says is Gaussian elimination. And what that is where you just try to remove out as many of the variables as you can in a systematic way. In particular, let's keep that top equation there, 2x plus 3y equals 4. Let's put the second equation here, x minus y equals 1. And I'm now going to try to subtract away a multiple. Let me replace the second equation by what happens if you subtract a multiple of the top one. Maybe I shouldn't just say words, we should do something. And so what I'll do, we'll use fractions. But I claim this is a systematic way to do this. With the top one, I'm going to replace the top equation. This pair of equations is going to be replaced with another pair of equations. And that other pair of equations, looks like this pen is running out of battery. The other pair of equations has the 2x plus 3y equals to 4, all divided by 2. So I have x plus 3 over 2 y equals 2. And I'll take the second equation and leave it as it was. X minus y equals 1. Okay? So that's fine. The value of doing this is because now the next thing I could do is I could go and take this pair of equations, and I could take the second equation and subtract the first equation. So I keep the top equation alone. The top one still says x plus 3 over 2y equals 2. But now, instead of the second equation, I'm going to say I wanted to take the second equation minus the first equation. Why not? I can do that if I want to. When I say I can do that if I want to, what I mean is I'll have another equation which is also true. In some sense, if these were true, then the next ones are true. I take the second equation minus the first equation. What does that give me? It gives me negative 5 halves y equals negative 1. Okay? So now I've replaced this with this. I will say that if you're thinking carefully about the math, you might wonder a little bit about whether every solution of this is a solution of that and vice versa. That's a little bit more sophisticated, but it turns out in the way that I've done this, it is. Okay, let's keep going. Well, now we've got something nice. If I've gotten that minus 5 halves y equals minus 1, I could figure out what y is. So let's do this again. Let's replace this with another pair of equations where the top one is still the same, x plus 3 halves y equals 2. And the second one is that y equals, let's multiply both sides by minus 2/5, and I'll get 2/5. So now that I know what y is, I'm sure that people here can try to figure out what x is. I see that the ISE Gacha channel says we have that y is 2/5 and x is, you say, what is this, 12/5, 1 and 2/5? Oh, this is the hard part. I have to actually do some arithmetic. So if I put this in, what happens? I have to multiply, and I get 3 halves times 2/5. That's 3/5. Okay. So ultimately, as I finish this whole thing up, what would I have? I'll just go and replace that pair of equations over there with another pair of equations, which is that x plus, we said that this was 3/5. Well, we said it's 3/5 equals 2. So I'm going to get rid of the y, and I'll say if it was x plus 3/5 equals 2, x equals 2 minus 3/5. Hopefully I'm right. Okay, 2 minus 3/5, let's simplify that. That's why somebody said 1 and 2/5, not 12/5. Okay, so 1 and 2/5, that's 7 over 5. Okay, so x equals 7 over 5, and I'll leave this still here as saying y equals 2 over 5. Okay, now that's another pair. Okay, sort of ran into my head, but I think you get the idea. Okay, so I could solve the equations this way. But you see, sometimes the way people that do this, sometimes when you do this, you say, look, all of these x's and y's were just in the same places. So maybe instead of putting the x's and y's, I could write down some shorthand to try to represent what's actually happening here. So some shorthand meaning, let's write down a matrix that represents what this is. When I took this class in school, when I took this class in high school in the United States, we often even wrote down stuff like this. We wrote down 2, 3, 1, -1. We drew a line, and then we drew a 4 and a 1, and we often did something like this. I don't know if this is how you guys still learn it today, and I'm already seeing that this pen is running out of battery, so I'll switch pens. Hopefully the other one works better. Okay, switch pens. And so I have here, this is a matrix. Is this how you guys do it in school these days? I'm curious. Someone's asking, with a drawing tablet or a regular pen and paper. I use a drawing tablet. That's how you get this thing here. But so I'm not sure if this is what you see here. If this is what you see in school. But this thing represents what's going on up there. At least that's how I did it when I was in school in the United States. And then what we did is then we said, if you see a pattern like this, what you can do is you can take the first row and divide the first row by 2. And that will give you an equivalent set of equations. 1, 3/2, vertical line, 2, 1, -1, 1. Maybe you get the idea that somehow this is just a faster way to do all of what we have just done, where we don't have to write the x's and y's. So actually, I saw someone ask, what are we talking about? Well, somebody asked about the shoelace formula for the area of a triangle. And so somehow I decided to start talking about equations. But the reason I wanted to start talking about equations is because this is the beginning of what we call matrices. In fact, matrices are something that you use to study systems of equations when you have many equations. When I was in high school, this is sort of what we did, and we just used these arrays, essentially, just like writing the numbers in this rectangular way, to get an idea of what the equations were. Later on, I learned that this was actually related to something much more sophisticated called matrix multiplication. It actually turns out that this equation, this first one, is equivalent to the statement where you take the matrix 2, 3, 1, -1, multiply it by the matrix xy equals, let's draw a better equal sign, equals the matrix 4, 1. Now, when I was in school, doing it this way was sort of enough for me to be able to solve the problem. But I'm drawing this because some of you, especially if you're taking Algebra 2, pre-calculus, or later, you have maybe seen something like this before. This is called matrix multiplication. And so if you multiply these two, this expression is exactly the same as this pair of equations up there. Why am I saying this? I'm saying this because it turns out that this shoelace theorem that you were asking me about is deeply related to something called the determinant, which I'm not going to talk about today. But the determinant is something that you get when you have a matrix. You can actually take the determinant of a square matrix. And why I decided to say all of this is because if you're curious at all about matrices, and if you're a teacher, it turns out that this evening from 5:30 to 7:30 Eastern Time, I'll be doing another live stream. But that live stream is actually for teachers. It's because I do something with Math for America, which is an organization based in New York City. And every single spring, I usually give 3 mini courses for professional development to help talk to teachers about math that I find interesting, I guess. That there's also math that maybe people can use to learn a little bit more about what's going on underneath. And in fact, by popular demand, the topic that I'm going to be talking about in this spring's mini course is going to be about matrices. So even though matrices are beyond the topic that we would talk about in this daily live stream, I decided to sort of tee this up here by saying, if you are a teacher or if you're curious how one might try to teach this entire concept of matrices and matrix multiplication, I'll be doing that tonight. And I usually do this at the Math for America headquarters, but they're in New York City. And right now, unfortunately, nothing is going to be happening in New York City. So I'll be live streaming it to all of Math for America. And that live stream will be open for anyone else who wants to watch too. I'll apologize in advance. I will not be responding on the YouTube live comments on that one because I'll be primarily interacting with the math teachers from all over New York. On the other hand, if anyone just wanted to watch because they were curious, you're welcome to. And then you'll get maybe a little bit deeper answer into all of these matrices. Okay, more questions. Andy Yu asks, what is a mod? Ah, you want to be a moderator. Well, unfortunately, moderators, we have to, we make the people moderators if they've been somehow working with us for a long time. So I guess stick with us for a long time. Maybe we'll get to know you through the courses or whatnot. That's not what you mean. You mean what's a modulo? You mean like when you say something mod something else. I thought you meant be a moderator. Okay, so to do modular division, let me say something real quick, which is useful. This is something where you might want to know what's the remainder when I divide something by something. So oftentimes we might write down a sentence that says something like this. We might write down, let's make up something, like 37. If I divide by 9 has remainder, what's the remainder? Remainder 1. Oh my gosh, that is such a long sentence. It's just not efficient. We wrote down too much stuff, too many words. It takes up too much space. Now, there are some other ways that you could try to express the same thing. What I learned when I was doing computer programming, there's a certain computer programming language, well, maybe many of them, where you just write down something like this, 37% 9, and it happens to be 1. I think this is true I know this is true in C and C++. I used a couple of these kinds of languages before, like Java or whatnot. I know that this is not true in some languages where percent happens to be a comment. If you wrote this in LaTeX, you'd be in trouble. But in general, this is something that you might see inside a computer program. It's a very efficient way to write down, divide by, and look at the remainder. So if you ever go and see percent signs, if you ever see percent signs in computer code, it could be that that's what they mean. And it's very useful because, for example, if I have, I don't know, some number of minutes and I want to break this big number of minutes into like hours and minutes, you just do everything percent 60. It's very useful. However, we don't use this way of writing in math because percent is already used in math. We can't use percent again. So this is only for computers. Oftentimes in math, for whatever reason, the way we write something like this is we say 37 is congruent to 1 mod 9. Okay? So if you ever see anything that looks like this is expressing something like that. But I said something like that. It's not exactly. This expresses more than just that. Or, well, also sometimes less. It expresses something related. So here's a statement that you'll often see written down. And what this 3 equal signs means is it means that these two numbers have the same remainder when I divide them by 9. It's actually more useful to have the 3 equal signs be that somehow they have the same remainder, and I'll tell you why. There's 2 reasons. The first is that lets you write more things. It is also, for example, true that 37 is congruent to 10 mod 9. This statement is also true because both of these have the same remainder when I divide by 9. Now, why might it be that it's more convenient to let this be congruent to something where the something is not just the remainder? Like somehow if I want to know the remainder, come on, just tell me it's 1, right? And why bother saying 10 first? The reason is because in math, whenever we write lots of equal signs, or like equal sign, or like 3 equal, we want it to be what's called symmetric. It's actually very useful for whenever you write down something like this, for it also to be true that 1 is congruent to 37 mod 9. I mean, it would just be weird if you said A equals B, but B is not equal to A. And here we're saying something is congruent to something else, and also the something else is congruent to the first thing. That's one reason. The other reason is if you write it this way to say they have the same remainder when you divide by 9, you're also able to write statements like this. 37 congruent to 10 congruent to 1 mod 9. And by the way, this statement that I just wrote at the end is the very natural statement you'd have if you used the divisibility by 9 trick. Some people may or may not have learned that a number is divisible by 9 exactly when the sum of its digits are divisible by 9. But what we went into much greater detail in the number theory course in the Daily Challenge, in our online course series, the full courses, we actually talked about how you'd use these congruent to symbols in a stronger way. And that actually helps you prove that you don't only find out whether a number is divisible by 9 or not, you even find out what its remainder is when you divide by 9. And so this chain of congruences is in fact what you'd see if you were doing this out in a more careful way. But again, in this daily live stream, I don't want to go too deep into any one particular course because the course is supposed to be, well, not supposed to be, a course would take longer to go and do this than we have the time today. Other questions? What do we have here? Let's see. I'm reading through comments. I'm trying to see what's here. So I'm looking at all of these different comments. This is, I see, and I'm also choosing. I'm choosing them based on what I think I can tell. I'm choosing the comments based on what I think I can tell an interesting story for. So I see that somebody has asked, what is it? Roderick Ma asked, excuse me, I've always had trouble finding slope. How do you find it? So maybe I'll just quickly talk about what the purpose is of the slope. The purpose of the slope is just to have an easy way of seeing how slopey a line is. And so what would that mean? Well, if I've got some line, how would I express the slope of this line? I mean, there are many ways. One way is you could just go and say, the ground is here. See the ground? The slope of the line, I could just measure, what's this angle? That actually seems quite reasonable. You could just go ahead and measure that angle, and if you measure that angle, what is this one? This one looks sort of like 40 degrees. And you might say that this line is at a 40-degree slope, and that would be fine. What I'm trying to say is that, you're allowed to define any notion that you want, and the notion will then be useful, well, if you can use it. Now there's a problem. How useful is it to know that the slope is 40 degrees? Well, now let's suppose we're trying to build a house. If you're trying to build a house, maybe what happens is that's supposed to be your roof. And maybe in a house, I should make it look like a house. Let's make a roof. Let's pretend that was also 40 degrees, even though it doesn't look like it. But so in this house we have here, presumably you know how wide the house is supposed to be. So the house is going to look something like this. Here, it looks like a house now. And your house has some width. How long is a house? How wide is the house? It depends where you are. I'm going to make up something simple. How big is 100 feet? I don't really know. This might be it might be a small house, might be a big house. Let's just call it 100 feet. This might be small, this might be big. Depends what country you are in, what you're used to seeing in terms of how tightly dense, how tightly packed everyone is as they live. For example, if you live in New York City, things are probably quite a bit smaller. Okay, so if you have 100 feet across and you have this 40-degree angle, well, now you might be curious, how tall is your house? And now you have a big problem. The big problem is called, what are you going to do with that 40 degrees? Because what I'm actually curious about is, I've got this house. Over here, let's draw a right angle. I guess this is 50 feet. As I said, pretend that it was symmetrical. I just had trouble drawing an exactly symmetrical thing. And now how tall is the house? Well, how tall is the roof? Oh, I don't know. That doesn't seem very useful. I need to do something with 40 degrees. What in the world could I do? I think that some people may have taken a class called trigonometry. And this is directly related to what we call the tangent of 40 degrees. But unfortunately, the tangent of 40 degrees, what would that be? What is the tangent of 40 degrees? I don't know. I mean, I actually don't know off the top of my head what it is. And so I have some trouble. So this is one notion of how you'd calculate the slope. There's another notion of how you'd calculate the slope, which is to say, look, I have this ground here. And I have this line, which has a slope. Now, maybe the way we'll calculate the slope is we'll say, you sort of went across by a little bit, and then you discovered how much you go up. That seems reasonable. So let's draw some arrows. Suppose I noticed that on this straight line, whenever I went across by 5, I went up by 4. I don't know if it's 5 inches or 5 feet, but whatever that is the same unit of measurement for the 4, so 4 inches or 4 feet. Well, since it's a straight line, it turns out, not just turns out, it is, that if I just were to do this again, well, I should go across another 5. And I should go up another 4, because it's like a straight line. It's all continuing the same thing. So in that case, if I look at how much I've gone all the way across, it's 10 and 8. So now, we could have a notion of saying, what is the slope? By saying, how much did you go up for every amount that you went across? That's why in America, we often call this slope equals how much you rise divided by how much you run. That's what it's called, how much you rise over how much you run. And if you look at this, the beautiful thing is it doesn't matter whether you took 4 over 5 or you took 8 over 10, they're the same. That's what makes a useful definition. It's that somehow the same thing can be used, and since you can use the exact same, the same formula, rise over run, and it works no matter which run you choose and which rise that corresponds to it, it's useful. And so when I say formula, it's like we do have to define slope to be something. So this is useful. Now let me tell you a story about slope. So this is how we talk about slope, and if you ever want to calculate the slope through 2 points, just calculate how much does it go up divided by how much it goes across. There are other ways that slopes are described though. We already described slopes as a degree measure, like what's the angle. Has anyone ever been, on a hill before? And when you're on the hill, you see some kind of sign. This is in America, you'll see a lot of these. And the sign looks something like this. And maybe I don't know if the sign has like a picture of a truck or not, but it says something like this. Has anyone noticed these road signs in America? And what does the road sign say? Does the road sign say caution, slope of 10 degrees? Or does the road sign say caution, slope of -1 over 7? What does it say? I'm a little curious. Has anyone paid attention in your car? What does it say in America? If you see one of these signs, it actually tells you how steep it is. Aha! So somebody says, Grace Yan says, it says grade 15%. You often see something like 15% grade. What does that mean? Does anyone know what that means? Somebody also saw 40% grade. What does that mean? I'm a little curious. If you have some idea, feel free to post in the chat, because this is the fun part. It's like math is related to real life. You've seen those signs before. It's the slope. Yes, okay, it's the slope, but what slope? What slope would 15% grade mean? I've drawn the sign for you. What exactly is happening? Where's the 15%? If I was actually going to draw the ground and the hill, what's 15%? It means you got an F. Yes. This slope got an F, but it's like 15 over 100. So what's 15 and what's 100? Can someone tell me? 15% of 360. That's an interesting point, I'll say at some point I thought maybe that's what it means. Maybe the grade is like what percent of the full rotation. Then that would be quite reasonable. Although I would say if it was what percent of the whole rotation, where 100% grade would be 360 degrees, I'm not really sure how it would work if you got to like more than 25% grade. Like, would you be upside down or something? I'm not sure. So 15 is the y and x is the 100. Chirag Samantaroy has an idea. I believe that's actually the case. So what you have here is that you have 15 and 100. So, you could of course express the slope as a percent. I'm just basically saying slope was rise over run. It's something over something, right? And so if it's something over something, it's a fraction. You could say my slope is 15 over 100. But I could also say that my slope is 15%. Now, there's a reason I said this. Because, it means that you could, in theory, have some pretty interesting grades. Does anyone know what I mean? What I mean is, what is 100% grade? If this were the case, what is 100% grade? 100% grade, does it mean that you're falling down a vertical cliff? Oh, this does not look like it's drawn to scale. You're right. It's not drawn to scale. I just drew this. Vertical slope, if this was what grade meant, if grade was the slope expressed as a percent, then what would 100% grade look like? A 45-degree angle. Yes, because if you had a 45-degree angle, what's the slope? Well, the slope is rise over run. At this point, we have, Eric Zhang wants to be in my video. Okay, that sounds good. So Eric, you are now here. I'm not sure if that's what you meant. But anyway, so Eric Zhang is now in our video, and he's on this slope of 100%. And so, it's going, if it goes up 5, it goes across by 5. And so the sign that's right here, would be a very, very frightening 100% grade. But of course, what you mean, what happens here is that you can in fact do more than this. 45-degree angle is not the steepest angle. You could in theory have a 200% grade. But somehow we don't usually see those on street signs, and there's a reason. It's because if you actually had something this steep, it is very, very hard for a car or a truck to try to go up that slope. So it turns out that somehow, even though you could in theory have more than 100% grade, in practice you aren't doing that unless you're climbing a cliff. Okay, great. What else can we do here? Other questions, other questions. I'm going to look and see, oh, these are some interesting questions. Okay. I see Diane Chung asked me, how many percent of the world will have COVID-19? Do you know? So that's a hard question. When I say that's a hard question, it depends on what we do as a population. So maybe I'll say a little bit of something about, what should we do, right? And this is related to an explanation that I gave. It was on the second one of these daily live streams. It was at some point last week, where I explained that somehow the way that a disease starts to spread starts exponentially. I won't explain that again because it turns out that recording is actually still available. But somehow the way that a disease starts to spread is that at the beginning, when every sick person is meeting another person who could get sick, who could get sick, who could get sick, it's like somehow whenever you go and meet 3 people, you quite likely can get all 3 of them sick. Then it grows what we call exponentially. The only time that it starts to slow down is when a sick person goes and meets like 3 other people, but those 3 other people, many of them are not susceptible anymore. They either already got it before and are immune, or maybe they're not there anymore. Maybe they passed away. But so in any case, it's only when a pretty big fraction of people have already gotten it, like maybe 10%, 20%. Those are huge fractions, by the way, because the Earth has 7 billion people. Only after a big enough fraction has gotten it, then it starts to slow. So it starts to slow. So this is called, let's call it percent infected. And let's call this time. It only starts to slow when you already have some big percent already infected. And when I say big, I mean even 10% is a big percent. Big percent already infected. And so what I mean is, if the only thing you rely on is somehow people getting sick and somehow eventually everyone gets immune, the only way you do that is you get a very large percent of the people in the whole world infected. I think that what's going on right now is that biologists and researchers are trying to find a way to maybe make a vaccine. Because as you know, fortunately, most of the people currently on this earth were never infected by polio or some of these very, very devastating diseases. And that's because we all got immunizations, we all got shots, vaccines early on. And so instead of getting the real disease, we just taught our bodies how to deal with if someday you ever came across that virus. Actually, polio might be one of these that you take orally in your mouth. But in any case, I already sort of forgot. But in any case, there are these various vaccines. And if we can get a vaccine, then we can make it so that not everyone gets infected. So my hope is that we will be able to have the appropriate measures so that we don't get that many people infected until we get a vaccine. How to do that? Well, working at it. We're working at it. Okay. Let's see. What can we do? Oh, Leo Yu says Amy was cancelled. Is that true? So I'll say I didn't follow the exact details. Amy, by the way, is not. He doesn't mean Amy got cancelled. He means Amy got cancelled. So it's not that the Amy got cancelled. He's wondering about this thing, which is the AIME. So we're not talking about that. We're talking about the AIME, which is the math contest that you take if you happen to score very, very highly on the AMC 10 or the AMC 12. So now, was it cancelled or not? I'm not entirely sure. When I was involved in chatting with some of the people who were organizing it, my hope was that it was going to be something that was not cancelled but only postponed. And my understanding is I think that everyone who runs math competitions is trying to find a way to let people do it remotely. I'll even tell you, I have an idea for how this could possibly be done. Whether it's actually what people use, that's another question. But I think that one could have, for example, these exams be proctored by somebody watching on a webcam. I mean, I'm just trying to say, in this world where we live in today, we need to figure out how to keep doing all of the things that we do, where we run things remotely with cameras or with a live stream that you have here, as opposed to having a person actually have to show up. And so what I think is, what's actually happening when you take an exam is that there's someone called your teacher just watching you from over there. So surely there should be a way to maybe set up a webcam and have it watch you for the 3 hours. Just remember, the AMY is a 3-hour exam. Watch them for the 3 hours in the same place that the teacher would have been. Well, then you won't cheat, right? I think that this would be completely reasonable. And furthermore, why I think this would be a good thing is because these days there are many people who unfortunately don't have jobs. Unfortunately, in many parts of the United States and the other parts of the world, people are staying at home, people are not going outside. This makes it difficult for, say, a restaurant to operate. This makes it difficult for a lot of places to operate. But maybe there are people who might want to help with this remote type of economy. There are probably a lot of people who might be willing to help proctor exams. Actually, proctoring exams is something that's going to have to happen at a huge scale soon, because in the US at least, every May, there's all of these AP exams, advanced placement exams in high school, and somehow they'll have to figure out what to do. Anyway, so my hope is that the AMY is not actually cancelled. My hope is that there's a way around this. Okay. Other questions. What else can we have here? I'm just looking to see what I should choose to hit here. Jack says ISEE. I'm not sure what that means, but I'm wondering if that's something from a different country, just because ISEE sounds sort of like AIME or something like that. I'm not sure how to answer that question. Let's see. Wow. Yeah, Amy Fan has some predictions of what percent of people will get COVID-19, and then, some percent of them will unfortunately die. So I'll say, I think one of our jobs right now as a society, using our math, using our research, using everything we know, is to try to make it so that it is not that 60% of the population gets COVID-19. I'm not ready to say that we give up yet. Actually, this is a general advice. I mean, to me, and also this is what I've been saying to our team who's working on this, in some sense, giving up and surrendering is not an option. Somehow, as long as you see a possible way forward, or even if you don't, as long as you can use your brain to try to think of a way forward, don't give up too easily and say, we'll have to have everyone get this virus. The outcome could be very, very bad if that happens. Okay. What else do we have here? Oh, Dan Ding says, ISEE is the Independent School Entry Exam. I see. I'll make some comments about entry exams. So I know that actually there are many different entry exams, many different tests you can take to try to get into a school that maybe teaches more advanced mathematics or teaches more advanced science. And here's an advice I'll give you. I've noticed that all around the country and all around the world, there are lots of people who try to prepare for these exams. And the way that you prepare for these exams is maybe you go to some test preparation center, and people will show you all of the techniques that you need to do those exams. And oftentimes it's like, watch, here's how you do this kind of problem. Now, when you see this kind of problem, you can practice like 10 of them and you'll be able to do it. Let me tell you a bit about my own approach to life. Whenever I see something like that, and I see 10,000 people who are using the exact same strategy to prepare for some exam, which is going to go and pick, 100 people or 1,000 people, I say, if everyone's using the same strategy, it's very difficult to go and say the strategy is actually going to work. In fact, the strategy is probably not going to work for most people because they're all using the same strategy. In that sense, my attitude to a lot of these things is, yes, there are indeed some specialized schools. Of course, you should try for it. But ultimately, what you should do is you should make sure whatever you're using to try for it is itself useful, so that if for some reason you don't get into it, at least you still got something out of all of that practice. And this is related to how some people have said things like, is it even worth it to prepare for math competitions? What's the point? Because these kinds of problems, you're not going to see these kinds of problems in real life, are you? Well, it depends how you're learning it, right? Because if the way that you learn it is just to go and copy someone else's methods and do this like every single day, yeah, that might not be very useful. You're just very good at being a parrot. But on the other hand, if you go and learn how to think instead, you'll get farther. And so that's in some sense where I come from. And that's also why the way I even do these live streams is I'm not going to prepare some class for you. I want to go and see what you have so I get to think too. I see. Let's see. So I'm looking at all of these different questions. Cow Animations asks, Pythagorean theorem, please. I'll say, I don't need to show that to you here because it turns out that I've already explained that fully online. If you go to the Daily Challenge website, it doesn't even require paying anything. It's in the free demo. So if you just go look at the Daily Challenge's free demo, that's the Daily Challenge's website, it has a complete walkthrough of the Pythagorean theorem that even explains why it's true. I recommend that instead. What else can we do? Looking over here. I see all of these different things. Michael Dong asks, Po-Shen Loh, do you like Trump? Say hi to a guy named Donald Trump, the president. Here's my attitude to all things. I think that, this world, there are lots of different people who have different levels of power. I've always had the conclusion that I aim to be as effective as possible, no matter who is the person that's responsible in charge. And so in some sense, that's why a lot of what I do is using mathematics, the internet, and computers. Why did I give you that answer? It's because it actually doesn't matter whether I like or don't like the person who's in charge. You are lucky enough to live in an age where, like you, just one person, if you get some crazy idea like, you want to live stream to the entire world, you can. And how much is it going to cost you to broadcast that live stream? 0. You're lucky. Maybe 30 or 40 years ago, if somebody said, I want to put a broadcast up to the entire world, they would have to pay a fortune because you'd have to go and pay the TV stations to put your live stream on. Why did I give you this answer? It's because, yes, we live in a world where there are governments. We live in a place where there might be people in charge of various things. What you need to do is to make sure you have as much capability as possible so that no matter what happens, you almost single-handedly or with a small team could actually make a huge difference. We live in an age right now where if somebody goes and develops an app, if that app ends up being installed by everybody because they find it's useful, then that tiny team was able to influence the entire world. So that's my answer to this. Justin Liu asks, infinity equals what? How in the world can I answer a question like this? Infinity equals what? That was the question. I'll just say that infinity helps us to represent a quantity that might be very, very big. It is not a real number. We actually just use it to put a meaning, to go and say something is very big. In fact, you don't usually use infinity until you get to calculus. The place where you will finally see infinity appear is when you see stuff written like this. You might see stuff written like limit as the time goes to infinity of, let's put on something simple, 1 divided by t equals something. Now, whether you've taken calculus or not, it doesn't matter. I can explain this, and I think you'll understand it. Lim just stands for limit. Okay, that's not rocket science. It's the limit. Limit means what's it going towards, but it never actually gets. What's it going towards, but it doesn't actually have to get to it. Does anyone know what this might mean? And I would say even if you have never even heard of calculus, you probably have a sense of what this is. It's like, what does it mean? T goes to infinity. Okay, so t is going to get bigger and bigger and bigger and bigger. What happens when you take 1 over a number and that number is getting bigger and bigger and bigger? Well, that's going to 0, right? That seems quite reasonable. 0. And so what we just wrote down here is a legitimate statement. So you see, infinity is it's not really a number, but here it's being used as a notation. It's being used as a way of writing down an idea called t is getting bigger and bigger and bigger. And so I'll say that's what I'll give you as my answer for what infinity is. It's not a number that you can do any calculations with, but you can use it whenever you have a clear understanding of what that meaning is trying to be. Other questions? Alex Song says 0. That's because you're answering that the answer is 0. I get it. I was like, what kind of question is 0? Oh yes, also infinity. Infinity is also sideways 8. Okay. Other things. What else can we see here? Somebody asked, Chibo Chen asked, can you briefly talk about calculus? To me, what I'll say about calculus is what happens when you try to do infinitely many, infinitely small things. That's sort of the basic principle of calculus. Because you might say, for example, if I do infinitely many steps, where every step I walk 1 foot, how far will you go? Well, you'll walk infinitely far. That's clear. It's like infinitely many things where everything is, reasonable size. But then you might go and ask a different question of what happens if I take infinitely many things, each of which is infinitely small. And I'll do a problem that you don't need calculus for, but I'll give you an example of how you can think about this. It is called the area of a triangle. So I'm going to draw a very simple triangle. This is a triangle which I've drawn on purpose to look like a 45, 45, 90 right triangle. But the slope is 1. Oh, we got to use that word. The slope is 1. Oh, we have to forget that. We can't forget that Eric Zhang is still here. Hi, Eric. Okay, anyway, so we still have Eric Zhang on this thing. It's the slope of 1. But somehow we have the slope of 1, and I want to find the area of this particular triangle. And let's give it some lengths. Let's say that this is 1. And let's say that this is 1. Now, a lot of people here who are watching this live stream are like, come on, the area of this is just base times height divided by 2. Yes, that's true. But I'm going to try to find the area of this triangle in a very weird way. I'm going to find it where I go and take some smaller rectangles and add them together. What do I mean? So let's suppose I broke this into 4 parts. That was supposed to be straight up and down. Let's break it into 4 parts, but each of the parts, let's go and make each of the parts a rectangle. Like this. I could do this if I wanted to. This seems quite reasonable. I could just go and do this. You might say, let's find the area of all these rectangles. Unfortunately, the areas of these rectangles will be bigger than the answer. Okay, the sum of the areas of the 4 rectangles is bigger than the area of the triangle. But don't worry. As I make more and more and more rectangles, my area will get closer. So what's the sum of the areas of the rectangles? How might I do that? Well, I guess I could try to write down what the first one looks like. It looks like I cut them all into 1/4, right? All of them have cut into like the bases of length 1/4. So for example, this is a 1/4, and this is a 1/4, and they're all 1/4. What are the heights? I told you that the slope is 1. Can anyone tell me what is the height of the very first rectangle? This one is quite nice. Ron Yoder said it would be fun to see the volume of a sphere derived a la Archimedes. That's pretty good. Let's save that for another one of these live streams. We can do that too. Although I think that might actually also be in one of our daily challenge courses already. But anyway, let's keep going. I see the answer that people are saying. The height is 1/4 of that very first one. This is 1/4. And of course it's 1/4 because the slope is 1. So when I went across by 1/4, I go up by 1/4. How about the height of the second one? The height of the second one becomes, well, you went across by 1/4 plus 1/4, that's a half. So you go up by a half. Good. 2/4, that's also true. Thank you, Jerry Chung. 2/4 is also true. But I'll just go and, yeah, why not? Let's write 2/4. Actually, I want to write 2/4. That's going to be more useful. And you get the idea. The third one has a height of 3/4. And finally, the fourth one has a height of 4/4. So what's the sum of the areas of the rectangles? Well, it's going to be 1/4 times 1/4, that's the first one, plus 1/4 times 2/4, plus 1/4 times 3/4, plus 1/4 times 4/4. I'm going to factor out the 1/4. Everything has a quarter. And it's a 1/4 plus 2/4 plus 3/4 plus 4/4. Okay, that's what happens if I cut it into 4 parts. Now, if I cut it into 4 parts, it looks like this, and I don't want to calculate that yet. What if I cut it into n parts, where n is very, very big? So that was with 4 parts. But what if I did this with n equal, no, they're n equal widths. They're not n equal parts. N equal widths. So now I have n rectangles, and those n rectangles, if I were to draw that, what would it look like? Let's pretend this is a slope 1 right triangle. Yes, we still have Eric Zhang up here. Easy, nice initials. Anyway, so what we have is we'll be doing something like this. I don't know if you guys can even see what I'm drawing, but I'm drawing something like this, and I think I'm too lazy to continue. It just keeps going And the last one looks like this. N equal widths. Hey, look, the area of all of those green rectangles is going to be basically the area of the triangle. Actually, as n gets bigger and bigger, it converges to, it gets closer and closer to, and eventually the distance between it and the area of the triangle goes to 0. Okay, so what's the formula then? The formula, instead of having 4s, all of the 4s just become n's. So let's look at what happened here. The n equal widths would be 1 over n times 1 over n plus 2 over n plus n over n. That looks like a minus sign. I mean dot, dot, dot. There we go. Dot, dot, dot. Okay, so we have this. So that happens to be this is the formula if I had n parts, n equal widths. What the point of calculus is to say, the point of calculus is to say, suppose I have infinitely many equal widths, and each of those rectangles has infinitely small area because it's really, really thin. What happens if you take infinitely many things, each of which is infinitely small? Could they possibly add up to something? Well, here you can. And the way you can do this is you can try to use some algebra to simplify this sum. What can you do here? Can you guys help me with this? If I want to simplify this, what's a good way to simplify this? I see a 1 over n in front. Okay. But I also see that everything else is divided by n. If everything else is divided by n, I could just divide by n, and I could have 1 plus 2 plus up to n. Now, can someone help me simplify that? I have 1 over n. Actually, it's 1 over n squared at this point. And what is 1 plus 2 plus up to n? What is that? Now, there's a formula for this. Yes, thank you. I see somebody already has written. Tian Chen has said it's n squared plus n divided by 2. It's actually n times n plus 1 divided by 2. And, okay, I can't just tell you a formula. The way I like to teach everything is to tell you where it came from. Look, how many things do I have here? I have n things I'm adding together. That's this n. And I'm going to say the sum is how many things times the average. What's the average number between 1, 2, 3, and up to n? Well, the average number is the same as the average of the first and the last because they're equally spaced. So the average number in this yellow circle is average of 1 and n, which is n plus 1 over 2. So that's why this yellow thing works. I have to do that because I can't just tell you something if I can give you a quick answer of why. Okay, great. So now let's simplify this. What do I get? This equals, we get to cancel, and n squared cancels an n with that n. What is this? This is equal to 1/2. There's a 2 here, and there's an n plus 1 over n multiplied together. Can anyone tell me what happens to n plus 1 over n if n gets really, really big? Eric Zhang, thank you very much for the compliments. Thank you. Oh, I should say it to the Eric Zhang in here. Thank you very much for the compliment. Okay, great. So now n plus 1 over n, what happens? As n gets bigger and bigger, like suppose you had 50 million and 1 divided by 50 million. Actually, that gets closer and closer to 1. N plus 1 over n gets closer and closer to 1. If you want to know why, another easy way to see why is because n plus 1 over n is equal to 1 plus 1 over n. And now that's pretty easy to see what happens. If you make n get bigger and bigger and bigger, we just saw that. That was this limit of t goes to infinity of 1 over t. So what happens is as n gets bigger and bigger, n goes to infinity, this goes to 1 plus 0, which is 1. Great. So that's how you find out that as n goes to infinity, I'm using your infinity now, as n goes to infinity, this goes to 1/2. We have just proved that the formula for the area of a triangle is, with this base 1 and height 1, is just 1/2 times 1 times 1, which is 1/2. You might say, that seems highly, highly inefficient. Well, this is just an example of what calculus can do. This is in fact called the integral of x. In fact, if you eventually do some calculus, you'll eventually find out that what we actually just did is we just did something called integral from 0 to 1 of x dx is equal to 1/2. We just did that. But, that's just a bunch of squiggly things right now. It doesn't matter quite so much what it is. What matters more is the thinking that's all underneath it. I have like one more fraction of a minute. Let me just go and take. Oh, Justin Liu, thank you. Thank you for the compliment too. But now look, this is my opinion about online classes. Somebody asked me, what's my opinion about online school? Here's what I'll say. I actually think that the interaction between teachers and the way that a teacher can try to help people be interested in something, I think that's very valuable. So I think that when we look at online school, something that I thought a lot about before was how can we try to make online school still have the benefit of, making people feel like there's a real person there. I'll say that there are lots of different ways that you can learn online now. In fact, people all have to learn online now. Most people do. And so if you can learn from your teacher, that's a great way. I'm actually happy to share tips for any teachers who want to do this kind of a broadcast, like how to set up a studio like this. But my opinion about what to do with, say, non-teachers, my opinion of what to do if you're looking for other resources that might be not necessarily using just what your teacher had, if you're looking for more things. My opinion is that online school has made it possible for anyone to go and learn all kinds of things. I think that's very exciting because when I was growing up, we didn't have online school. And so you were limited. You were limited to just finding whatever is around you. Today with online school, what I encourage everyone to do is to go and check out all of the different resources that they may have heard of. Go and look for what works for you. And in the end, I actually think it's a good thing that right now we have a bit of flexibility that lets everyone go and experiment and go and find out what works for them. I have some opinions about what I would do, and in fact what I do when I teach an online school. And you can see it's because I think that somehow the person is very important. And so for me, what an online school is it's a combination of things like these daily live streams, which kind of run across lots and lots of different topics, together with things that are more systematic. And of course, that's what we do with the rest of the Daily Challenge online courses. But no matter what, I think that the human component is very important. And so if I can't be with you live, we have to find ways to try to bottle that up and make it feel as fresh as possible whenever it's opened. I think that we're living in a funny time right now where we're finding out how to use this blend of pre-recorded and live different streams at the same time. I think this is very interesting, and as a person who likes to play with technology, I think we're just opening the box to see what can happen. I see people are saying the green shirt. I have to remember to go and get this green shirt together. Okay. Well, unfortunately, that's all the time we have today for today's live stream. I want to thank everyone for coming, and if you liked what you saw, please help us to spread the word to more people so that we can keep bringing more and more people into this interesting world. And in that case, as I said before, I'll still be having an online stream tonight, but that online stream tonight is focusing on teachers. In fact, I'm going to assume that everyone in the audience is a math teacher, and they want to maybe think about matrices. If that's what you're interested in, you're welcome to come. I will not be able to reply to the live chat because I'll be working with the teachers in a separate channel. But this is just a way that you'll be able to watch as you go. I will say we might not have comments enabled only because of the fact that this is something that's supposed to be directed at the teacher audience. And when I say not have comments enabled, it's only because I'm not sure we'll have enough moderators, enough mods to watch for 2 hours. Okay. But in any case, whether I see you there or whether I see you another time, like tomorrow or another point in our life, have a good day.